Thank you and welcome everyone. Thanks for coming. Thanks for being so punctual. And I know it's been a long day, so thanks for showing up in these so great numbers. As was said, my name is Anastassia and I'm presenting work where the mastermind is actually not me. The mastermind behind this is my colleague Ane. She's a fellow PhD student. We're both at the University of Copenhagen and our supervisor is Michael Sill. So that's about us as the team behind BikeDNA. And before I start explaining what BikeDNA is, just for me to get a sense of the room, can I maybe see a show of hands? Who of you works in Python regularly? Okay, I would say like more than half. Who works with urban planning or transportation planning? Okay, some people. And who are passionate about bicycle infrastructure? Okay, that's great. That's very encouraging for us, of course. Before we dive into what this tool can do, BikeDNA, just to give you a bit of background of what motivated us to create this. So we are researchers, we work in academia, and we work with bicycle networks, mostly in urban contexts. And what we see a lot at the level of the data is that cycling is marginalized. And cycling is marginalized, I guess most of you will agree with me, both in urban landscapes, so at the level of how much space is actually allocated to bicycles versus other modes of transportation, but also in data collection. Yes?
Can you shut the please?
Sorry? Okay, is it better now? Okay, wonderful. Now you can see the slides. Yes.
Does it work for the video without the lights?
It's bad.
It's better. Good. Okay.
Trade-off.
So let's move on.
Okay.
He said it's bad.
It's bad.
Really? Not bad. No, it's not good. Really? It's not good.
Is there like half?
So please, in the back end, can you roll up the blinds, please? See if we get a compromise. The other way. Okay.
Yes.
Can you just remove that?
Oh, yeah.
Because it's touching on the
Yes. Okay.
I hope they cut this off from the video.
Yeah, we can make a time lapse. Okay. Yeah, so as we were saying, cycling is marginalized. That's what we see as researchers, and that's also what we see when we bike, just as people on the street cycling. That's also what we experience. And so what we need, I think, when I say we, now I mean everyone who somehow works with bicycle infrastructure data. We need access to data, for sure, that's the first thing, but also we need to know if the data that we have access to, if it fits for purpose or not. So that's the big motivating question behind BikeDNA. And also what I want to say here is that we care much more about topology. So we are network researchers, so we work on the level of the whole, like we try to see the network as a whole. And topology is what we're really interested in. What we're less interested in is the accuracy of the mapping. So we're leaning more on the topology side. And with that, so what BikeDNA can do is it helps you assess bicycle data quality. And what it is essentially, it's a workflow in Python in Jupyter notebooks, so it's not a full package, it's a set of Python notebooks. The reason being that the target audience, it's all people who work with bicycle infrastructure, so also policymakers, for example, who might not have that much knowledge of GIS applications or Python. And then, so what you provide as a user is a study area of your choice. And then what BikeDNA does for you is it runs an analysis of the bicycle infrastructure data in OpenStreetMap, the one that is available for this area. Then, if there's a reference data available, for example, from the city or municipality, you can run an analysis on that reference data as well. And then you can also compare the OpenStreetMap data versus the reference data. So in more technical terms, the first two options, when you just take one data set, either OpenStreetMap or the reference data, and then you run an analysis just based on that, that would be an intrinsic analysis. And then the other one, where you compare OpenStreetMap and the reference data, that would be extrinsic, so comparative. And what you see here is a workflow, a full workflow of BikeDNA. I'm not going to walk you through all the technical details. You find everything quite, I would say, well documented on GitHub. That's what we were aiming for, to document everything very well. And what I will showcase in this presentation is just the analysis and the output of the analysis. And again, there's a lot of different outputs and results from the analysis, so I will not be able to show everything. I will just show you some examples of what BikeDNA can do. And the use case that I chose, it's a city not too far from here. Does anyone know which the city is? Can anyone guess? I blinded out here the name of the city. Maybe somebody can guess by the shape.
Yeah.
Sorry?
Is it here?
No.
Tirana.
No. It's Sofia in Bulgaria. And for Sofia, we have reference data from the municipality. And then we did the analysis for both the reference data and the OpenStreetMap data. And I'm going to show you some results. So for example, when we start with OpenStreetMap data, BikeDNA produces a set of plots where you can visualize what tags on OpenStreetMap are missing specifically for bicycle infrastructure. And I'm giving two examples here. The first one is the tag for surface. So it's maybe a bit hard to see. So it's colored from 0 to 100% missing data. So the very dark red grid cells that you see here, those are the cycling infrastructure data that have no information at all about surface. And the very light ones, yeah, I'm sorry, it's hard to see, but here, for example, you have a full information about surface. So you can compare this also how the missing information is distributed in space. And the same you can do, for example, for the tag lit, so about lighting conditions. And here, actually, what you see is quite a common pattern that in the city center, most of the tags are there. So this is like very light red. So most of the information we have. And then as you move outwards, outside of the city center, you see that the information on the lighting conditions is missing. And another thing that you can do with OpenStreetMap data is you can also compare whether there are several potentially competing tags that are all used to identify bicycle infrastructure. So if you work with OpenStreetMap, you might know that the tags are sometimes competing or contradicting, and this is a way of visualizing where this actually happens. And I chose just one of the examples. Yes?
Speaking too much noise, sorry.
Okay, not them. Should I put it here or?
And here, just to put it on the side. Thank you.
Okay. Is it okay now?
Yeah.
Can I go? Okay. Yeah, and apologies, it was kind of last minute. I used some Google Map imagery, but yeah, there you see an example of where this actually happens on the OpenStreetMap data, that you have several tags that both indicate a cycling infrastructure that might be competing. So you see the real world situation. So this was for OpenStreetMap. Now moving on to the also intrinsic analysis, but now for the reference data for Sofia Plan, so from the city. Another thing that BikeDNA can do is it can visualize all the over and undershoots that you find in the data. And here, I was told that there would be maybe problems with the internet, so I didn't bring the actual maps, but BikeDNA produces HTML maps, like interactive maps, where you can actually zoom in and look at the data in more detail. And what you see here is now just a screenshot without the additional layers. And also here, an example from what this looks like in real life. So apparently here somebody so there was like the cycling route was tagged on the whole street, and then just the intersection got tagged additionally, and this produced this undershoots that you see here. And then more on the maybe theoretical side, you can also get an overview from BikeDNA about all the different quality metrics, what has been computed. I'm not going to go through all the rows. It's a lot of different data that you can analyze. Just to highlight maybe, for example, what you see is the infrastructure length separated by whether the infrastructure is protected or unprotected. And then, so now to the maybe more interesting part of the analysis, that would be the extrinsic analysis, so comparative, between OpenStreetMap and the city of Sofia data. And again, another example of what BikeDNA can produce and compare. So this is a plot of all the disconnected components in the network. So each component has a different color, and again, it might be a bit hard to see, but I think you will agree with me that this looks kind of patchy on both sides. And what's important to remark here is that you cannot know, if there's no ground truth, you cannot know whether this patchiness in the data is a data quality issue or whether it actually correctly represents a very patchy network in real life, right? So that's, I think, also a good moment to maybe stop and say that, of course, all the outputs here, so BikeDNA doesn't provide you with a final decision on is the data good or not. It provides you with a lot of different information so that you, if you know the area and you looked at the data set, can actually take an informed decision about the quality of the data set. So that's more the idea here. And here, if you look closely, or very closely, you see in comparison the examples in OpenStreetMap, you see there's like one component in blue over here. There's a long way, like a long cycleway along a highway. And then in Sophia Plan, this is actually mapped as many, many different small connecting components. So you see that all in different, like you see it in different colors. And then so you might ask yourself, so which one is the better data set? And then of course, so this depends on what is your purpose. Because if you want to find like smaller gaps in the data, then maybe Sophia Plan is actually the better one, because if you zoom in and you look again at the conditions, this is just an example screenshot taken from this very long cycle highway. But here the cyclists, they come from over here, and then they have to cross there's not really a sign for crossing, and then there's a bus stop, and then there's another crossing, and then the cycleway continues here. Oops. So that would be a gap in the network actually. So it depends on the purpose for what you want to use the data for, whether you want this gap mapped out or not. And then the last feature of the BikeDNA tool is that it actually also does some feature matching between the two data sets. And what you see here, on the left side, you see all the OpenStreetMap data, and the color blue is matched and red is unmatched relative to the reference data set. And then on the right side, the other way around, you see the reference data set, and the color blue is matched, red is unmatched relative to the OpenStreetMap data set. So as you might notice on the right side, it's the city of Sofia. I think over 90% actually of the reference data set, so of the data set of the city of Sofia, could be found in OpenStreetMap, which is kind of a good result. And you can also look a bit closer at the feature matching and compare, for example, on the level of protection, whether the features, so now the colors mean something different. So now you see all the features that could have been matched and that are found in both data sets. And you see in blue where they agree about protection level, and you see in red where they disagree about protection level. So of course the red ones are the more important ones, or the more interesting ones maybe to see. So the data sets have some contradiction about, is this a protected bicycle lane or not? And you see an example here. So OpenStreetMap said that this is a cycle lane, so unprotected, just cycling together with the cars, just marked by some paint. But the city of Sofia was actually saying, and we discussed this also in a research group, and we kind of agreed that, of course, the physical protection here is kind of minimal. And also here, the cycleway just ends, and then you don't really know where to go because the cars come from the other side. Is that my phone? Oh, okay. But yeah, so in a group, we kind of agreed, okay, this is actually, we would count this as protected. Again, like you might discuss this, but there's some physical barrier here. So here we actually agree not with OpenStreetMap, but with the city of Sofia in terms of definition.